Hello everybody. In today's lecture we will discuss the Ampere's circuital law. Okay, so what is this law all about and what is it used for? The Ampere's circuital law is like the Biot-Savart's law. It is applied to find the magnetic field due to a current carrying wire or a current carrying conductor. So first of all, the statement of the law. According to this law, the line integral of the magnetic field over a closed loop is equal to mu naught times the net current passing through the loop. What is it? The line integral. What do you mean by line integral? Line integral means we have the magnetic field B dot dl and you take a small length. This B dot dl and you integrate this is called line integral. Why is it called line integral? Because you are integrating with respect to length. Okay, so it says the line integral of the magnetic field over a closed loop is equal to mu naught times the net current passing through the loop. So that is B dot dl is equal to mu naught into I. What is I here? I is the net current passing through the loop. Okay, let us prove this law. Okay, to prove this, let us consider a wire. Let's say you have a straight wire. Okay, so this is a wire and a current I is flowing through the wire. Alright, so obviously whenever current is flowing through a wire like this, there will be magnetic field all around the wire. Okay, so let us take a closed loop. Let us take a closed loop in the form of a circle. Okay, let me take white. So we take this kind of a closed loop. Alright, and this loop, the radius of this loop is, let's say, r. That means from this point to this point, let's say, the radius is r. Okay, now this loop, you can take this to be the direction of, okay, tell me what will be the direction of magnetic field. Alright, the direction of magnetic field on this loop. So let us imagine this loop to be on this plane. Let's say it is on this plane. On that plane. So this part of the wire is actually coming from down. Are you understanding my diagram? So actually what is happening here, this wire is coming and at this point it goes from below and the wire emerges from below like this. So you are actually looking at the top face of the loop. Okay, the top face of the loop. So what would be the direction of magnetic field? We know that whenever we want to find the direction of magnetic field, we have to apply the right hand thumb rule, right? So according to the right hand thumb rule, if the current is going up, then the magnetic field will be going anti-clockwise direction. So at this point, what will be the direction of the magnetic field? Let me draw magnetic field with yellow. At this point, the magnetic field will be in this direction. Okay, let me use a scale, that will be better. It will be in this direction. It will just be tangential. Right, that is the magnetic field. Okay, alright, now to apply the to prove this Ampere's law, we have to take a small length of this loop. This is a closed loop. Let us take a tiny length of the loop out here. This length dl. Okay, now if you look at the length dl and the magnetic field, what angle are they making? The length dl and magnetic field, they are along the same line, so they make an angle 0 degree. Got it? Okay. The magnetic field due to a long straight wire is given by B is equal to mu naught I by 2 pi r. Let's call this some equation 1. Now this equation 1 is an equation that we will derive later on. So right now we are just using this. This is a known expression. Okay, don't ask me, so where from you getting this? I will derive this later. I'm just assuming that I already know this. Okay, it is a known expression here. Alright, so therefore let us perform this integration. Integration b dot dl. B dot dl will be what? Will be integration b dot dl. Let us apply the dot product. That will be b dl cos of the angle between b and dl. And like I told you before, that dl and b, they are making an angle 0 degree. Yes, so that will be integration of b dl. Why? Since cos of 0 degree is 1. Okay, so let's put the value of b out there. B from equation 1, that is mu naught I by 2 pi r into dl. Okay, let's take this mu naught I by 2 pi r outside. So you are integrating only dl over a closed loop. Now tell me, what will be the value? I'm taking this small length out here, and if I integrate, I will get the entire length of the loop. In other words, I will get the circumference of the loop. And we know that the circumference of a circle is how much? Twice pi r, isn't it? So this value, the value of this integration, what is its value? Its value is 2 pi r. Okay, so let me write here. So this implies b dot dl, this is equal to mu naught I by 2 pi r into 2 pi r. So this 2 pi r and 2 pi r will cancel. You get mu naught times into I. Proved. A very important law, and also the proof of this is very important. Alright. Okay, now what are the conditions on which this law is valid? This law is actually valid only for steady current. Okay, only for steady current. The reason is because only steady current can produce a constant magnetic field. It is not valid if the current is alternating in nature. That means if it's like alternating current, AC. Okay, remember these 2 points. Okay, so the Ampere'S circuital law, it is like the Biot-Savart's law. The statement is this, mathematically, integration of b dot dl. What is this circle? I think you know this. You have seen this kind of an integration before when we applied the Gauss law. You remember? This is called a closed integral. So your b dot dl is what? This is called the line integral. Okay, why is it called line integral of magnetic field? Because you are integrating with respect to length. The line integral of magnetic field is equal to mu naught times the current passing through the loop. Okay, so for example, let me just give you an example here. Suppose let's say you have a loop something like this. Let's say you have a loop something like, and mind you, this loop, it not necessarily that it should be circular. Okay, not necessarily. It can be any loop, can be this shape also, as long as it is a closed loop. Got it? Not necessarily that it's a circular loop. Okay, and the wire is passing through the loop like this. Let's say this wire is passing like this, all right, and a current I is flowing out there. So what will be the magnetic field? How do you find the magnetic field? You apply this. B dot dl is equal to mu naught I. But suppose if this wire comes back like this, comes back like that, right? And now this current is going that way. So what will be the net current? The net current passing through the loop now. The net current will be 0. Why? Because this current entering is cancelled out by the current leaving, the same current. Okay. So since net current here is 0. So in that case, what will be the magnetic field? The magnetic field here will be 0. So that's just one important point that I want to make out here. So next lecture we will discuss the various applications of this law.